Hey everyone. So, as you're all diving into becoming software engineers, you're learning how to build some really incredible applications. But here's a question. Have you thought about how to stop hackers from breaking them? That's what we're digging into today, the whole world of application security. We're going to look at the tools that help you make sure your software isn't just cool and functional, but actually secure.
Yeah, this quote absolutely nails it. I mean, getting your software to work, that's really only half the battle. Because if it's got weaknesses, if it's vulnerable, you're not just risking code, you're risking user data, your company's reputation, everything. Security can't be an afterthought, something you bolt on at the end. It has to be baked in from the very first line of code.
And that's the million-dollar question, right? How do you actually find those weak spots in your code before the bad guys do? We need to be proactive to go on the hunt for these vulnerabilities ourselves, and that's exactly what we're going to get into.
All right, so before we can talk about the solutions, we gotta understand the problem. Let's set the stage, Think of it like a crime scene. The dangerous world of cyber threats that our code is up against every single day.
And that brings us to this foundational idea, secure coding. Look, this is not just some checkbox you tick off before you ship the product. It's a whole mindset. It's about weaving security into every single part of the process, from the initial idea, through development, all the way to deployment. It's about building a fortress, not just putting a lock on a flimsy door.
So what kind of crimes are we talking about? Well, here are some of the big ones. You've probably heard of these guys. You've got things like SQL injection, where an attacker can literally hijack your database, or cross-site scripting, also known as XSS, which lets them run nasty code inside your users' browsers. These aren't just hypotheticals. They're real threats, and they are exactly what our security tools are built to sniff out.
Okay, so how do we fight back? How do we catch these vulnerabilities before they do damage? Well, it's time to meet our two-star detectives. They both hunt for clues, but they have completely different and totally essential ways of doing it.
First up, we have SAST, which stands for Static Application Security Testing. This static part is key. Think of SAST as your inside detective, the one who gets to examine the architect's blueprints before the building is even constructed. It scans your actual source code, line by painstaking line, searching for potential flaws in the design itself. And the amazing part, it does all this without ever having to run the program.
And then we have our second detective, DAST, Dynamic Application Security Testing. If SAST is the blueprint inspector, DAST is the undercover agent sent to test the finished building. It doesn't know anything about the internal wiring or the source code. Nope. It interacts with the live, running application from the outside, just like a user would. Or more importantly, just like a hacker would. It's rattling the doors, checking the windows, and poking for any way to get in.
So, we've got our inside guy and our undercover agent. Let's put them side by side and really break down their different methods. This is what we call the white box versus black box approach.
Okay, this table lays it all out perfectly. On one side you have SAST. We call it white box testing because it's like you can see right through the box. You have full access to the source code. This is the developer's view, right? And because of that, you can run it really early in the development lifecycle, catching problems before they even get compiled. It's awesome for spotting things like design flaws deep in the code structure. Now, flip over to DAST. That's black box testing. Here, you can't see inside the box at all. You're testing it from the outside, just like a hacker would. This happens much later, when the application is actually up and running. It's fantastic at finding a totally different class of problems, like issues with authentication or server misconfigurations, things you would never see just by looking at the code.
All right, that's enough theory for a minute. Let's get practical. Let's open up a case file and see what one of these vulnerabilities actually looks like out in the wild and how our detectives would spot it. Okay, so what you're looking at here is a classic textbook example of a cross-site scripting attack, or XSS. See what's happening? Some user, let's call him Bob, isn't just typing his name. He's actually injecting a piece of malicious JavaScript right into the website's URL. The web application, because it's not properly secured, just takes that script and runs it, popping up that alert box you see. Now think about our detectives. A DAST tool would find this by actively trying to inject little bits of code just like this. And a SAST tool, it would have scanned the source code and screamed, "Hey, you're not doing anything to stop users from injecting scripts here."
Yeah, seeing that little alert box pop up is not good. It's proof positive that you've got a hole in your defenses. So, the big question is, how do we fix this? How do we write our code so this kind of attack is dead on arrival?
Well, we've got two main lines of defense here. First, there's input validation. Think of this like a bouncer at a club.
It enforces strict rules at the door. For instance, your username can only be 8 characters long and it must be letters only. If the input doesn't match the rules, it doesn't get in. Simple. Then we have data sanitization. This is more like a cleaner. It takes the input that's allowed in and scrubs it, actively looking for and removing any potentially harmful characters, like that less than symbol that started the script tag. The goal here is to neutralize the threat.
And a really specific and powerful type of sanitization is called encoding. This is pretty clever. Instead of just deleting the dangerous characters, encoding basically translates them into a safe version, so that the less than character gets turned into something that the browser understands it should just display as text on the screen, not interpret as the beginning of a command. It's a super effective way to diffuse attacks like XSS.
Okay, so we've met our detectives, we've seen their methods, and we know some defense strategies. Now let's zoom out. Where does all this testing stuff actually fit into the grand scheme of building software?
This right here is the software development lifecycle, the famous SDLC. And the key thing to remember is that security isn't just one little box. It's a mindset that needs to be part of every step. But our two detectives, SAST and DAST, have a special home right here in the testing phase. SAST, our blueprint inspector, gets used early and often, right inside the development step. DAST, our undercover agent, comes in later, testing the whole application when it's assembled and running, right before deployment.
Now, of course, SAST and DAST are not the whole story. There's a whole world of security out there. You've got penetration testing, or pen testing, which is like DAST on steroids. It's where you hire ethical hackers to actually try and break in and exploit the weaknesses they find. Then there's API security, which is a huge deal, protecting all the ways your apps talk to each other. And you've also got bigger architectural ideas like sandboxing. This is where you isolate an app in its own little playground, so if it gets compromised, it can't do any damage to the rest of the system.
So, if there's one single thing you remember from all of this, let it be this. SAST and DAST are not competitors. You don't pick one or the other. They are partners. They work together. SAST finds the problems in the architectural blueprints. DAST finds the problems by trying to break into the finished building. You absolutely need both to build a truly robust, secure application. It's all about that layered defense.
Look, at the end of the day, every single piece of code you write and put out into the world is going to be tested. The only question is, who's going to test it first? Your team or a hacker with bad intentions? By using tools like SAST and DAST, you give yourself the home field advantage. You get to find the flaws and fix them on your own terms. So as you go forward building the future of software, the real question is, will your code be secure? Thanks for watching.